Okay, we're now live. So I just hope everyone can see my screen and everyone can hear me. Okay, so um da- 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 da. Mm, okay, let me try to refresh here. Okay, it's cool. So close. Okay, so today we'll be going through the computer science to a practical zero memorandum, right? So let me open it. Let me open the practical. Then I'm gonna do this, minimize. And then I'm gonna zoom in. Right, so this is just a pretty easy practical, so there's not much to do. Okay, yeah, that's good. At least people can see. At least people can see my screen. That's good. So let's start. So the requirements are pretty straightforward, right? So I will use VS Code. For this practical, for the first few practicals, you guys will be required to use anything, any tool that you like, whether that's Eclipse or IntelliJ or or VS Code or Notepad++ or just Notepad. You can use everything else except for Microsoft Word, right? It needs to be a purely text-based app, right? It doesn't add any special characters. So I will use VS Code. It's one of the most popular text editors out there. So let's see. So create a Twang class. The class loops through numbers from 1 to n inclusive and prints out that number unless one of the following conditions occur, right? So that's pretty much what's going on. We're just going to output if it is divisible by that number, if it do output banjo or guitar or harp. So it's a very basic application. They're just trying to get you guys used to this environment, right? Get used to doing practicals and doing batch files. So before we start, let's talk a bit about batch files, right? I'll still create the Twang class, right? So I'm gonna click on new file here to create a new file. And then I'm gonna make it a Java file. You might not have this option. Improve this extension by allowing collect read deny don't collect data. So you might not have this feature, right? So I'll show you another way of doing it if we don't have this feature. That provided you're using VS Code, right? If you're not using VS Code, then it's cool. You don't have to you don't have to follow do exactly what I do. So we have this, right? I have this file. So what I would do is I'll just don't save, right? And then I'm going to create just a text file, right? A normal text file. And then I'm gonna press Control Shift S to save the file, right? And then I'm gonna locate where the file should be saved. The important thing is to remember where you've saved the file, because remember, The first few practicals that you guys are going to do, they'll be based they'll be based on um, they'll be based on a text editor. You're not using an IDE yet, so you need to be very careful of the location since you're going to compile and do everything via the terminal. So you need to be very careful of where you're locating the files. So after creating the file, when I'm about to save the file, right, I'm gonna choose the file type. I want to save it as what type? As a Java file, right? So you're gonna you choose Java because you want a Java file. This is a longer way of doing it. If you wanted to do it in a simpler way, you would do this. You'd go to that location. So for example, this is downloads, right? So I would right click here and then I would say new and then text document. And then instead of .txt, I would put .java. That's another way to do it. Me, I'm just going to do it inside VS Code. And then I'm going to give it a name. Remember that the extension helps the computer determine what type of content that file has and to also help the computer to decide which app to open based on the extension of the file. So if I write .java file, it helps the computer know that, oh, this is a Java file. It is Java code or Java source code. Remember, it's called source code. So they said the class should be called Twang, right? Or Twang, however you want to pronounce it. So you see, they said create a class called Twang, or yeah, I'm going to call it Twang. So remember one important rule about Java, right? In Java, the name of your Java file or the name of your .java file should correspond with the name of the class. So since we are going to create a class named Twang, we're going to name the file twang.java. And then I'm going to click save. And then this is a whole Copilot thing, right? This is what I do not like about these features, right? I do not like let me see if I can't. Okay, that's fine. So I have VS Code now has Copilot, right? Which can like do things for you, right? It's an AI system that you can use to create. You see, it generates code for you, which is a problem. I do not want that feature. So let me let me say disable completions for Java, right? Yeah, I don't want it to complete for me. I want to write it myself. So if you're using VS Code, things become a bit easier, right, to code. So remember that when you start, it's going to be empty. So you need to create a class. So you're gonna make it public because you want everyone to access whatever's inside the class. And then remember what we talked about, the name of the Java file. Since it's called twang.java, you should also name your class twang. Or else it's not gonna compile. We discussed this in the previous tutorials, so I suggest you go back and revise or rewatch those videos. And then I'm going to create a main function, right? Because remember, every single application, in every single programming language, you always need a main function, which serves as like the entry point. So basically, what that means is that when the compiler or the translator looks at your Java code or Java source code, it's going to start at the main function. So hence the main function plays a very important role. It always needs to be there. The compiler only compiles what's inside the main function. So since I have VS Code, I could just do this, right? And you see auto completion done, right? Straightforward. But then since you don't have those features, okay, you can use VS Code, it's fine. But I suggest you type it on your own so that you get used to it. So it's public static void main and then string. It's an array of strings, right? Or an array of command line arguments, right? And then there we go. This out. Oh, okay. So it's kind of similar to Eclipse, which is the IDE that you guys will use. So it's fine. Um, so yeah, so let me make a simple application, right? So I'm gonna say sys out, which will just help. It's like an abbreviation to add system output, right? You just type sys out, and if you wanted to do sys error, right, you do this. So that's the nice thing about advanced IDEs or text or advanced text editors. You can save time. You can save time. You don't have to type everything. So there we go. I'm just gonna output a simple text, right? I'm gonna say output hello world, right? And then none is a non-project file. Only syntax errors are reported. Java. Uh, I think it needs me to put it in a package. So let's try doing that. Yeah, Java projects packages are very important. So let me do this. Let me save my changes, right? I'm gonna press Control S, and then let me create a package, right? A package is basically a folder, right? It's a way to group your classes, you group related classes into one folder. That's basically a package. In simpler terms, that's basically what we call a package. We'll get to packages later on. This first practical is straightforward. We don't want to go into too deep. So I'm gonna call this package main, right? And then I can just close this file there, and then I'm gonna drag and drop it inside and put it inside this folder, right? So now it's inside the folder named package, or named main, or in other terms it's inside a package called main. And then VS Code likes to make sure that you trust things and whatever for security reasons. So I'm just going to accept, and then there we go. So there's the file, right? So I could just do this, right, and say package main to say that it's part of the package main or part of the folder main, right? I'm going to do that because sometimes it tends to, okay, let me see, does not match. Let's leave it. Let's not get into packages. Let's leave it. It's giving me unnecessary errors. So there's a simple program, right? So for you guys, since you're not going to use an IDE yet, not yet, maybe I think when you get to practical two or practical two or practical one, so you need to open the terminal, right? So I think you go to view and then no, not command palette. Okay, it's view and then so you go to view and then you scroll down to terminal, and then it opens the terminal. Remember what I talked about. In order to run Java, we're going to use the terminal. So the nice thing about VS Code, right? It already it already puts me inside the folder that has the Java file. So I don't have to locate it or try to go there via the terminal. Or there's many ways to approach it. Or another way to do this is you go to that folder, and then you can right click here and say open in terminal, right? And then you say open in terminal, and then it loads, and then you see it's in the same location. Then you can just type dir to see everything that's inside the folder. As you can see, there's the twang.java, so I'm in the right folder. And another way to check if you're in the right folder, you can look at this part here. The last name represents the folder or the directory that you're in. Another name for folder is directory. Hence, this word dir, it comes from the word directory, which just means to list everything within the current directory. So I'm currently inside the main directory. So there's many ways you can approach it. You can open it in this way, open it that way, but then I feel like the most convenient way is to open it within VS Code. so that your code is right there and then your terminal is right there, which is very convenient. It's like two in one, right? You have two in one. You have the text editor and the terminal within one application. So you can see that the dir command still works because it's still the terminal. There's the file twang.java. And then you can clear the terminal by typing the command clear, right? So it clears everything that's currently on the screen, on the terminal. By just typing clear, it clears everything on the terminal. So let's try to output to code to run this program, right? Remember, the first thing that we need to do is call javac, which is our compiler, right? Java C or Java compiler. The C short for compiler. So Java C compiler, right? To compile our code, we need to provide it the name of the Java file that we want to compile. And we must provide the name of the Java file that has a main method. Remember that it can only compile something that has a main method, because when you call the compiler, right, the Java compiler, it goes into that file and it looks for the main function. So if the main function does not exist, we have issue. We're gonna have issues. So as you can see, my Twang class has a main function. So it will find an entry point, which is the main function. So I'm going to say javac and then twang.java. Then it's going to compile. If something went wrong, it was going to report it back to me. But nothing went wrong. It did all the work behind the scenes. But then now, since we've compiled it, remember it's going to generate a .class file, right? If you check in our folder, there's the .class file, which is basically what it's actually called Java bytecode, but it's basically like the computer's language, right? It's like it's been translated to the computer's language. But in Java, it's not quite the computer's language. Remember, Java, you see that it's kind of, some things you can read, right? Some things you can see. We're using the print stream, right? Remember, we did output, so we are printing. So we're using the print stream to output or to print the output. What output are we printing is hello world. And then there's other things that are there that we cannot understand. And our source file is twang.java. All of this is done behind the scenes, right? Java knows how to interpret that, or the Java virtual machine. So now we have the bytecode or the Java bytecode, right? Which is sort of like an intermediary between the source code and the machine language code, right? Or the machine code. So sort of like an intermediary, like an in-between, a middleman, right? We are, like I said, we're not quite there yet. We haven't fully translated the source code. Basically we haven't translated this into the computer's native language. It's just been translated halfway. You can picture it in that way. That's Java bytecode. Then now let's run it, right? So we're going to use the Java command, right, and say Java to run. And then what are we running? That .class file. So this over here, right, this part over here, it will force Java to call the Java virtual machine, right? That Java virtual machine, it expects a .class file. Hence, we compiled it first so that we generate that class file. Once we have the class file, that class file gets passed into the Java virtual machine, and then the virtual machine translates. It finishes the translation, right, depending on the operating system. In my case, I have Windows, so it's going to translate it to the mother. Basically, remember, the computer, they can only speak their mother tongue, right, which is the native language. They can only speak zeros and ones. But then those zeros and ones, or that native language, it differs between operating systems. Hence, Java decided to come up with the Java bytecode approach, whereby it doesn't finish it translates it, right, but then it translates it in such a way that it's like in between. It's not specific. It's not a language that's specific to an operating system. So we still need to translate it to that language specific to that operating system. How do we do that? We take that Java bytecode and pass it into the Java virtual machine. So let's pass it now into the Java virtual machine. And then after I press enter, we should see hello world, because I've passed that. And remember what we talked about when you're running your Java files, right? Your class files. You don't append the .class extension. You don't put it. When you put it, it's not gonna work. So let me try and make that mistake and say twang.class. You see that it's gonna show you an error. It'll be like it failed to load, blah blah blah. There's rules to this thing, and you need to follow. You need to abide by the rules, right? You need to follow the rules. Don't put the .class extension when you're running Java, the Java bytecode. And then there's our program hello world. And then after a while, my screen is gonna be full. So let me expand it a bit. So you're gonna see that as time goes on, right? The the screen, come on, the screen becomes full, right? And then from time to time, I need to clear the screen, and then clear, right? The screen is cleared. This becomes cumbersome, right? It becomes irritating, because now every time, what if I change something, right? Let's say I just added a space, that's it. I would actually have to compile it again, then it generates Java code, and then I run the Java code again, Java byte code. So I would have to say Java C twang.java and then Java twang, right? And then it outputs hello world, which is a problem because now I'm repeating myself over and over and over and over. Isn't there a convenient way for me to like avoid repeating myself? There is. But before we get into that, let's learn a few commands, right? So let me open this. Let me open it in a. So I'll do it this way. I'll code inside VS Code, and then I'll run it via this terminal, because I want to zoom in here so that you can see what I'm typing, right? So I can type dir, right? That's a command that you type to list everything within the current directory. How do you find the current directory? You look at the last name here. That means that's the current directory. That's the folder that I'm currently in. Or it even shows you here. It tells you that this is the directory that you're in. You first go to C drive, then users folder, this theta folder, downloads folder, then the main folder. So I'm actually within the main folder. And then we have these files within that folder, which is true, because if I go back to File Explorer, there they are. These are the files. So that's true. The files are there. So now we now know one command, right? Which is a very useful command, because back in the days, the GUIs are not there most of the time, right? They were not there. So most of the time they use the terminal. So imagine you're running the whole operating system via the terminal. Everything you do, you are doing it via the terminal. If you want to take a picture of yourself, you take it via the terminal. So everything was terminal based until things evolved, and then now we have GUI, graphical user interfaces. Now we have buttons we can click, we can see. So that's why sometimes it's very important for a developer to know how to run terminal commands, because sometimes you get a computer. Let's say you're doing cloud computing, right? So the computer is on the cloud. It's not a physical computer. So you'd have to log in. It's like logging in to check your marks, sort of like that. But then when you log in, you can run and operate in a laptop at that way on that website. So that's basically cloud computing. So when you run it that way, you only have access to a terminal. So that means you need to know terminal commands. So that's why we are teaching you these terminal commands. So remember, dir is just an abbreviation for directory, which just means list everything that's within the current directory. Then we have clear, which means clear the terminal. Or in Windows, it's up to you. Remember, I'm using PowerShell, right? PowerShell kind of supports both, right? It kind of supports both. I can say CLS, or I can say Clear. But then Clear is mainly for Unix and Linux operating systems, right? Unix and Linux based system operating systems. So you would have to use CLS. But then if you're using PowerShell, it's fine. You can use Clear. There's two. Just be careful. There's this thing called command prompt. That one you're forced to. If I open this one, right? Let me open command prompt to show you that there's a difference. If I type clear, it's not gonna work because the command prompt it's mainly Windows based, right? You see, it's made by Microsoft Windows, so it's for the Windows operating system. So what's the equivalent of clear in a Windows operating system? You type CLS and then it clears the screen. So that's why I'm saying it's kind of there's kind of a lot going on. You choose which terminal you want to use. So I'll give you sort of like both the commands if you're going to have it. But then some commands are similar. You just need to remember that if you open it with command prompt, you see CLS, and then you can also search PowerShell by typing power, and then there's PowerShell, right? Just choose the one that says Windows PowerShell. Don't choose all the different ones. Just choose the one that simply says Windows PowerShell. So there we go. I see everything that I saw everything that was inside of my folder by typing dir, and then we also learned about clear to clear the screen and also CLS to clear the screen. So now there's another powerful command which is called echo. So echo, it literally means echo, to echo back what you have said. So to say basically it says back what you wanted to what you've said, right? So if I say it's like for example when you're in a tunnel and then you scream, if you especially if you're in or in a under the bridge or in a tunnel, especially in a tunnel, when you scream, there's echoes, right? So it's a similar concept. So I can say echo, hello world, right? It just means say it back to me. What should it say? What I wanted to say should be placed within double quotes. So I should say hello world. So everything within the double quotes will be said back to me. So it's going to echo that text. So you see, it said hello world back to me. You might not see it as a useful thing, but then it's actually very useful when you're working with your when you're working with your what is this your batch files, right? Because sometimes you don't know what's currently going on, so you need to use echo so that the user can see the status, can see how far they are, how far is the batch file. So echo is important in that sense. So you can also just say echo without any double quotes, right? You can just say echo hi, that's it. You can also do that. So there's two ways. You can say echo with no double quotes or echo with double quotes. It will still say back the tech that thing that you wanted to say it back to you. So we know echo, we know dir, we know clear, we know CLS. Now the another very important one is CD, right? CD stands for change directory, right? Where the C comes from the text change, from the word change, and the D comes from the word directory, right? So that means I'm changing directory. Remember, directory is a folder, so that means I want to change the folder. So if I want to change the folder, I need to pass in here. You see where there's question marks. I need to pass in the name of the folder that I want to move into, or that I want to go into. And you can only go into the folder if it's available. So for example, within main folder, right? Is there any folder here? No, there's none. So I cannot say, let's say for example, cd, so move into so I advise you put the backslash before the folder name, because if you look at how Windows operates, that before the folder name, it always puts or appends, it's not appends, it prepends the backslash, right? So it's going to prepend a backslash or add a backslash in front before it lists the folder name or the directory name. So you can do it this way, right? And then I'll press enter, and then you see that there's gonna be red on the screen, and then you're gonna start panicking. Do not panic, try to understand the error. It says it cannot find the path example, so it couldn't find a folder named example, right? But then another important thing that you need to understand, right? Terminal is very tricky. You need to be well versed in what you're doing. So you see, I just typed backslash example, and look at where it started looking. It started looking at the C drive. And where's the C drive? That's like the root directory for all folders. You see, these are all the folders. But why is it looking for it here? I wanted it to look for it within the current folder. How do I tell it to do that? So I need to clear my screen and tell it cd change directory again. I put a dot. So dot, it means within the current folder. Then I can say backslash example like this. Then you see now it's now looking in the right location. So it's telling you that within C drive, within users folder, theta folder, downloads folder, main folder, within main folder, there is no example folder. It says because it does not exist. But then previously it just went to look for it in the C drive, which was wrong. So the computer is very tricky. The terminal is very tricky. You need to be very careful with how you're typing things. That dot there, it makes a huge difference. So cd dot and then backslash example, which is true because within the main, if I go back to downloads, right, and then I open the main folder, do you see an example folder here? No. So hence that's why it's telling me that there is no such folder, and that's true. But then if it did exist, right, so let's just create a temporary folder. So example folder, and then cd. So I'm just, if you're tired of typing the same thing, right, remember we're going to create a batch file for that. But then another convenient way is to press the up arrow, right, to once you're tired of typing the same commands. The up arrow, what it does, it goes to it goes through all the previous commands that you've typed. So let me see if there's any questions. Okay, so no questions yet. So when you press the up arrow on your keyboard, right, it's going to look at all the previous commands that you ran or that you typed. So I don't have to type all the time. So if I keep pressing up, you see that it remembers all the commands that I've typed, even the ones way before this class, before this stream, right? I was learning Golang here, so it still remembers all those commands that I've typed. So I want the command whereby it allows me to change the directory. So let's try to change the directory, and as you can see, it successfully changed the directory. And now it's no longer inside main, now it's inside example folder, because the example folder exists. So that's something that you should understand. So now since we understand cd change directory and the dot, now we need to understand two dots. So you can use two dots like this. You can say cd space followed by two dots. The two dots just mean it basically in an advanced way, it basically means the parent of this folder. So basically it's a folder before this current folder. So basically the folder that contains the current folder that I'm in. So which folder contains example folder? It's the main folder. So that means it'll go up once, right? It's gonna go backwards. Or you can view it in terms of backwards, that's up to you. So I'm currently inside example. I want to move into the folder before this one, which is main. So it will move into main folder. So if I press enter, you should see that it now moves into the main folder. So that's something you should understand. One dot means the current folder, two dots means the previous folder, right? And then now I'm just gonna clear my terminal because now it's just untidy. So we understand a few, we have an understanding of the basics, right? Let me see, did I, okay, I didn't, did I install, okay, totally forgot to install Notepad++, but that's fine. I'll use VS Code. So we understand the basics of the terminal, right? We understand how to run how to compile by using Java compiler and things like that. So now let's begin with our practical, right? I know it's a simple practical, just that there's quite a lot of things that you need to understand before you start. So let's see. The other commands, right? There's way more commands that you can learn. You can go study them on your own. There's mkdir. There's a lot of commands. You can go study them on your own spare time because they're not really important in this practical. So we're not gonna go into them that much. So use the variables you created. Use JavaScript to compile the source code found in source folder and output to the bin folder. Yeah, a lot of students they get chowed by batch files. It's really annoying. Batch files are really annoying. It gets better when they start giving you the batch files, but for now you're gonna have to make the batch files on your own. So let me see. I hope I still remember the setting the Java home part, but I still the variables and what those are not an issue. So let's create the batch file and see how far we can go. If I've So let me delete that. So to create a batch file, right, you can just right click on your keyboard and click new and then new text document, right? They said you should call it batch and the extension should not be txt, it should be BAT. BAT, which is an extension that means that it's a batch file. It stands for batch file. The operating system will be able to pick it up as a batch file if you add that extension. So are you sure you want to change it? Yes, I'm sure. I know what I'm doing. And then you can now open it inside Notepad. So didn't I install it? Yeah, totally. Let me quickly do that. Let me open this and then download Notepad++. Notepad++ is better than the plain old Notepad. So let me quickly download that and then install it. Okay, just wait for it to load. Yeah, there's quite a lot involved when you're working with Java, with especially these first few practicals. There's a lot involved. You have to understand command line. You have to understand command line keywords and things like that. So let me install this and then install. Okay, so complete, finish, and then open it, and then nope. I should have chose never, but it's fine. So let's open our page file, right? So I'm gonna go inside main, and then I'm going to open it, edit inside Notepad++. There's also another very important, what is this? Another important command, right? That that you can put type inside the terminal. So this command is called pause, right? It means to pause so that you can see what's going on inside your batch file. Or else if you don't pause, you won't see what's going on. It's just gonna do everything quickly, and then it quickly disappears, and then you won't see what's going on. So it's gonna be like the Flash. For those who know the Flash, it's gonna be like the Flash. It's just gonna be like fast. It displays fast and then it deletes. So we don't want that. So we're gonna need to put pause at the end. But then, in order for you to see that, to see the problem, let's try it first. So I'm gonna say Java. Right. So I know that the Java file is within this folder, right? Within the current within the folder, it's in the same folder which the batch file is in, right? So the .java file is inside the same folder as the batch file. So I don't have to change directories, right? I don't have to use cd. So remember, we always start by compiling. So java c, and then what are we compiling? The name of the file is twang.java, right? And then after compiling, we need to run the file. And we know that if the Java file is named twang, that means the .class file with the bytecode will just be this same .java file without the .java extension. So it will just be Java. And then to put comments, you just type in rem, right? REM. That's how you put a comment. And then anything after rem is considered a comment. So I'm gonna say compile my Java source code, and then here run the byte code, right? Yeah, so that's the part that runs the byte code. So okay, run byte code. Okay, that's fine. So once you're done, do not forget to save, right? Remember, you're inside Notepad++. You must always save. So you can click at the top there. You see there's save all and there's save. Since you only want to save the file that you have currently opened, you're just gonna click save. Or you can press Control S, right? And then it saves. So how do you run the batch file? Simple. There's two ways. You can run it via the terminal, or you can just double click it. That's how powerful the batch file is. So I just double click and then it runs. You see what happened? Everything just happened so quickly and then it disappeared because I didn't put in a pause. Remember, remember what, if you know English, you should understand what the pause means, right? To pause. When someone tells you pause, it means like just stop, right? It's another way we can say it's synonymous to the word stop, like just stop right there, right? So basically freeze, right? So I'm gonna make the computer pause to see output, right? So what happens is when you double click the batch file, it actually shows you the commands that are being run step by step and the output. But then we can't see that because we didn't pause. So I'm going to type pause like this. So this will pause whatever's in, so that I can see what happened. Did everything go successfully? And then you're going to click save. So I'm going to go back here and then you could refresh, right? Click refresh at the top because you've updated. It's important to refresh. And then I'm going to double click and then you see the difference now. It did execute like it did previously, but then the only difference now is that I can see the output. So you see that what I told you, that it executes everything line by line. So there's the command rem, and then there's that command, and then there's the comment again, and then there's the command, and then there's the output. I can see, oh, it ran well, it ran successfully because it said hello world, right? And then now you can tell it to, so now it waits for you to, you must press any key in order to exit. That's the nice thing about the pause command. Now I can press any key. So I'll just press enter and then the terminal closes. So that's pretty much what the batch file will be all about. So for now, let's leave it like this, right? Let's leave it as basic. We'll add all the extra things that we need to add once we've solved the problem. So let's solve the problem. It's actually a very simple problem, just that I still need to cover for loops. This session is going to be quite long. I think it might be roughly 2 hours. So let's see. Let's just cover it because it's important to understand what you're doing before you do it. I think we talked about, I'm not sure if we talked about variables. Yeah, I think we talked about variables, data types. Yeah, we talked about that, variables, data types. And I think we also talked about loops. Am I mistaken? Did we talk about, can you see my screen now? Because some of you cannot see my screen. Can you see my screen now? Just type in the comment section and let me know if you can see the screen. Because I am sharing my screen. Everything is fine on my side. As you can see, this part here, this is the screen, so it should be sharing as usual. Can you see my screen? Can any of you guys type in the comment in the chat section? Okay, so that's fine. So let me think. Did I talk about data types? I'm not sure about loops, but I did talk about data types. Data types I can remember. Oh, I think I didn't cover, yeah. I stopped the data types. The thing is, my memory is a bit fuzzy. I'm thinking I did talk about it, but then I didn't. Thinking about another day. Yeah, there was a day where I talked about it. I don't know whether it was another session, but yeah, I did explain loops. But it's fine. I haven't explained them in the recent videos. So we're gonna start with if statements, right? And then we will go to for loops. So I won't cover too many things. I won't cover the things that are necessary for that practical, right? So I won't talk about switch statements. There's also switch statements. We're not going to talk about that for now. We want to talk about if statements and for loops. So there's a variety of for loops, right? But before we understand that, let's understand the operators, right? So remember, we're dealing with we did. I think we did talk. No, we didn't. There's quite a lot we didn't talk about. We didn't talk. There's relational operators, right? Then there's logical operators. So these operators are very important to understand. But then some of them, a majority of them, most of them, from high school, right? So we have under relational operators, right? I hope I'm using the right term. So under relational operators, we have less than, we have greater than, then we have less than or equals to, then we have greater than or equals to, then and then we have equals to, right? So we have less than, greater than, less than or equals to, greater than or equals to, and then equals to. So with equals to, you're going to use two equal signs. Why? Because one equal sign is called the assignment operator, right? It already has its own role, right? It's meant to assign, right? Remember when we talked about variables as boxes, whereby we can put in things inside the boxes, right? So the assignment operator does that process, right? The process of putting things into the boxes or putting things into the variables. That's what the assignment operator does, right? So hence we're going to use two equal equal signs, right? To represent something, just to represent when something is equal to something. So when the left hand side is equal to the right hand side, we're going to use two equal signs. So this should be pretty straightforward. This operator should be pretty straightforward. The only thing that was a bit that I could say is a bit confusing is the equal to operator, which is this one. It you get used to it as the more you practice. Remember, practice makes perfect. So you just need to code on a daily basis, and then it's just gonna become second nature. So we have logical operators. So the logical operators that we have is and or. So let me put them into separate lines, or and then not. Right. So this is logical and then this is logical or. Then this is logical not, right? So, well, what do they do, right? Remember, okay, we for not everyone did calculus. Yeah, not everyone has done calculus to that extent. So I'm gonna assume that not everyone knows logic, right? So with and with logical operators, right? What are logical operators? They return a true or false. Just know that they return a true or false. And then this true or false is typically called the Boolean value, right? It's a Boolean value. Why is it called Boolean value? So they return true or false. They're called Boolean values or Boolean values, right? Why are they called Boolean values? Because the person who came up with logic, right, with the branch of mathematics that involves logic, was named George Boole, right? That was the mathematician who came up with the with logic, right? So they just took it from his last name and then they called it Boolean. So yeah, so these are called Boolean values. So they basically return true or false. So true or false, for example, if let me make a real world example. So for example, you can before you go out, right? Remember before you go out, you always ask yourself this question, or you can look outside and see, is it raining? If it is raining, which means that raining is true. If raining is true, it means that yes, indeed it is raining. Then I should wear a coat, right? Or I should grab an umbrella. Else, I should not grab anything. I should just go there with my shirt or shorts and slippers, right? Because if it's not raining, then we're going to assume it's going to be hot. So it can either be true or false. So true, when it's raining, that means true, it is indeed raining. Or false, no, it's not raining, right? So that's in basic terms, that's what logic is all about, true or false. So in terms of true or false, how does the logical AND operator handle it? So the logical AND operator, right, it only evaluates to true if both operands are true. So what do we mean by operands? So operands are those values that are being the values of which we're applying the operator to. So what do I mean by that? So for example, if I say 2 plus 2, right, what is the operator? The operator is plus. What are the values am I applying the operator to? It's this value on the left and the value on the right. So those values on the left and the values on the right, they are called operands, right? Because the operator operates on those values. So in a way, you don't have to overthink it, but in a way you can. I just want you to understand the term operator. In a way, you can view it in such a way that the operator is like the doctor who specializes in it, right? He specializes in that operator, right? So for example, I have the addition operator. So that means this doctor, his only job is to add numbers or is to add things together. Let me not let's just say objects. Let's not think of it in terms of numbers because you can also have things like strings, right? So let's view it in terms of in a general aspect, right? So 2 plus 2, the plus is the operator, which basically means in other words, it's like the doctor who specializes in addition. That's what he specializes in. He adds numbers. So that's an addition operator, right? This is the operator, the addition. It does what? Addition. And it's a operator. So addition operator. So the things that it's operating on, remember it's a doctor, he operates, he does operations, right? So is the doctor is going to operate on two things, one thing on the left and one thing on the right. So it's going to be like this, left, and then we have an operator here in the middle, and then we have a right, something on the right. So the things that are on the left and right, we call those operands. Basically, the thing is the things that the doctor is operating on. So this plus or this addition operator, basically the doctor who specializes in adding numbers, he adds the whatever's on the right to whatever's on the left, and then he comes up with a new value. So he has operated on those operands. So I would like you to view it in that way or in that aspect, that there's two things that the doctor operates on. This is a doctor specializes in only one thing, which is adding two things together. So taking two things and adding them into one or combining them into one. So the answer here would be 4. So that means the doctor or the addition operator has combined the two operands into one thing, into 4. So yeah, that's something that you need to understand. So now we understand what operands are, right? Is the two things that are being operated on by the operator. Remember, we have an operator, the person who's operating, like the doctor, right? Who's doing the operation? He's the operator. And then we have the operands, which is the values or objects that are being operated on by the operator, by the doctor. So, for example, the patient would be an operand. We'll call that an operand because the patient is the person or the thing. In this case, it's a living object. It's a living object that the doctor is operating on. So, hence, it's called an operand. So, try to understand those terms. That the terminology is very important. So, we understand operands, the term operands, right? So now I'm just gonna use it since we now understand it. So what about logical AND? Logical OR. Logical OR, it's only true if either operands are true. So if either of the operands is true, it becomes true. So if any of them is true, it becomes true. So that means if the left hand side is true, then basically when I say it evaluates true, right? I mean the result of the whole thing. So in this case, when you're adding two numbers, the result is 4. So in this case, I'm saying the result will be true because remember what we talked about, logical operators, they only return true or false. They don't return numbers or strings, or they only return true or false, which is a boolean. So we now understand that OR returns true when only if and only if one of the operands is true. So for example, if I have let's make an example, right? So let's say I have int x is equals to 10, and then int y is equals to 2, right? So let's say I want to I want to apply the logical OR operator. So let me make an example. I'm gonna ask the question, right? I'm gonna use relational operators to check. So y less than x, or is y greater than x? Right? Just a simple question, right? This should return true or false, right? Because I have this logical operator. And in terms of the order, right? Remember, um, remember, for those, the thing is, there's different ways of doing these things. Remember BODMAS, right? For those who know BODMAS, and then some they know it as PEMDAS, right? PEMDAS just meaning parenthesis, right? So the parentheses um, they have a higher order, right? So that means they are prioritized first. So after that, we look at any exponentiation, right? Like x to the power of 2, 3 to the power of 5, things like that. Exponentiation, followed by multiplication, division, addition, and subtraction. So PEMDAS or BODMAS is basically what we're applying here. So I'm looking at which operator has a higher order. So so you can, to make it simpler for yourself, you can put parentheses to sort of like see how it's going to work. So what's going to happen is that it's going to evaluate this, right? The relational operators is going to evaluate them, and then it's going to evaluate the logical or operator last, right? It's the last thing that evaluates. So that would mean that the relational operators have a higher order, meaning that they have a higher priority compared to logical operators. So keep that in mind. So we ask the question, is y less than x, which basically means is 2 less than 10? No, this will be false, right? So this will be false. So the left side will be false. What about the right side? Is y greater than x? No, it's not false, it's true. What am I saying? This is true. And then is y greater than x? Is 2 greater than 10? No, it's not. So this will be false. So what is the result of true or false? So how do we get to that conclusion? We look at the rule. It only evaluates to true if either operands are true, if any of them is true. So in this case, I have one true here. So that means the whole result is true. So that means this will result into true. So that's pretty much what we mean by logical operators. So that's what they do. We're trying to evaluate that statement logically, right? That's the fundamental thing about logic. Once you understand these operators, you understand how logic works. And then the logical not, right? Just it all it does is just negates the truth value. Another term for Boolean value, they're called truth values, right? So true or false, you can call it truth values or Boolean values. That's up to you. So it negates the truth value or the Boolean value. So if you say not true, that will be equals to false. If you say something is not true, what do you mean? In other words, you're saying that statement is false. That's what it means right there. But we are putting it in programmatically, right? In terms of code. So if I say not false, it means that my statement is true. It's not false, meaning that it's true. So it's like a different way of phrasing it. You can phrase it using not. So not is very useful. It might not look like it now, but it's very useful. So we did talk about operators. We understand logical operators, and these are the relational operators, right? Those ones we know, right? And then we have the last operators, which are the arithmetic operators, right? This is your plus for addition, to add, and then to subtract, minus to subtract, and then for multiplication, right? You guys are used to x as denoting multiplication, right? In Java, we use an asterisk, which denotes multiplication. And then we have division. This is what we call integer division, right? Don't don't confuse it. If you use this forward slash right in code, you're gonna get back a quotient. That's why I'm calling it that's why I call it integer division, because we take we take two integer if we take two integers, right, we're actually doing it integer division, meaning that we only get the quotient and not the remainder. So to get a remainder, there's special techniques for that. We'll cover that when we have to. So we have that, and then for exponentiation, right? If you want to say something is to the power of, you would have to say math dot power, and then you pass in the base and then comma the exponent. That's how you can do exponentiation, right? So math, right, is the math class. That's the class. And then dot, remember dot, we use that to access or to go within something to fetch something. So we go into something to fetch something else. So it's like you're opening your what is this? Let's say your purse, right? For the ladies out there, you're opening your purse and then you take out a phone. So the purse would be the math class. The phone would be the power function because it's within that thing, right? So the power would be your phone because the phone is inside of the purse. So that's how I want you to picture it. So we have the class and then there's a function within the class. And as you can see that we have a class here. We'll get into all, I think we did cover, did we cover? No, we haven't. We will cover OOP when we get to it. For now, it's not necessary to think about it, right? Just know how to work with, yeah, just know how to work with the class. That's all you need, the math class. Then there's other functions. We're not gonna get into those that are inside of the math class. Even pi is also there inside the math class. Even Euler's constants, right? So math.pi, and then Euler's constant, which is e. You just say math.e, and they are all part of the package java.util.math, right? So they're inside the basically, remember what I said about package, it's folders. So basically it's inside the Java folder, and within the Java folder there's a util folder, and then within the util folder you see it changes now. It's an uppercase letter, meaning that it's a class. So within util folder I have a class called math, or basically I have a math.java file, because remember what I talked about, the rule. The name of the class, which is twang, should match with the name of the file. So twang.java. So that's how I know the class name. And if you don't believe me, you can try to locate where you've installed your, what is your compiler, right? Try to locate where you've installed your compiler. I think it's inside here. Yeah. So go to C drive and then program files. There's program files 86 and program files. Just choose the normal program files. Within program files, you see Java, right? That's where the JDK is, the Java Development Kit. Then you go within the Java Development Kit. Then I think it's inside, is it lib? I forgot where it is. But then this is where the files are, right? Is it bin? No, it can be bin. Let me just double check. It can't be bin. I doubt it. Yeah. Okay. But then some of the things you can find here, but I doubt it's bin. As you see java.exe. So when you run Java, it calls this application here. And then there's also Java C. There's Java C for compiler, and then Java dog for Java dog. So all of the files are here. So view the packages in this way. I want you to view it in this way to really understand programming and not just be guessing things. Oh, I think it's here. It's league. Let me see. U. Where's U? RST. Okay, this is not. It's not here. I'll find a way to find it. But then there is a folder with that math class here. Just that I haven't went into too deep into the files, into the structure, into the JDK, the folders. I haven't been inside of them. So, but then I know it's here. So that this is where it's located. So it's inside the Java folder, and then the Java folder should have a util folder or directory. And then within the util folder or directory, we have the math class, which is saved under math.java. So that's pretty much packaging. It's just folders. Putting a folder within a folder, and then within that folder, you put in the class that does. It's sort of like you're dividing your classes, so you're not mixing up your files because that can lead to confusion. For example, if you have a very big app, right, it needs to be divided. Hence, there's packaging, there's packages. So we understand relational operators, we know arithmetic operators, we know, and just be careful, right? This over here, it returns a double. Just be very careful. This returns a double. So if you want it to be an integer, you have to convert it to an integer. We'll get to that. In this case, I don't think we need this function. Yeah, we don't need it in this practical, so I'm not going to touch on that. So we talked about that. Let's talk about if statements, right? So there's quite a lot to cover. There's quite a lot. So we talked about logical operators, right? Logical operators, right? Let's talk about the data type called Boolean, right? So let me do this. Let me change it to Java so that it highlights. So there's this data type in Java called Boolean, which just means it stores a Boolean value, which is true or false. So I can have, for example, is raining. I'll call my Boolean variable is raining and then semicolon to terminate. And then I'll say is raining. I'll set it to true. Because let's just assume it is raining. Where I currently am right now, it is raining, so therefore I'm going to set it to true. And remember, you can combine these two steps into one step. So you can just come here and say it's equals to true. So I'm going to do that to save code. So Boolean is raining is equals to true. So the data type is Boolean, meaning that it stores a logical value, right? The truth value, true or false. So that means in order for me to get the result, I can only use and, or, and not, right? So let me create another variable whereby I'm just going to demonstrate a few things. So I can have is not raining. How can I get is not raining? I can do it in a more advanced, unnecessary way because I can just simply say false to say yeah. Is not raining? No, no. Okay, no. It's not gonna work. Logically, it, let me just. You shouldn't do this, right? I was thinking about it. It doesn't make any sense for me to create a variable and name it is not raining and set it to equals to false. because that would just mean yes, it is raining. So you get what I'm saying? So I'm just gonna rename it is rain, give it the same name as raining. Remember, this won't run if you put it inside code. I'm just doing for demonstration purposes. Then I'm gonna call, okay, let me say it's not running one, then it's running one, and then it's running two. So I can say false is raining, is raining two is equals to false, meaning that it's not raining. So another way to do this, I can use the logical operator not and say, and use is raining one. Because it's raining one, I know that it is raining. So I'm going to say not raining, meaning negate that truth value. So it's going to go there and check the truth value, or the truth value is true. It comes here, it replaces that truth value to true. What is not true? It's false. So it's just set it to false. So like I said, it's an unnecessary way of trying to set a variable to false. But I'm showing you the flexibility of the Boolean data type. That's how flexible it is. So now since we understand the Boolean variable, Boolean data type, and because Boolean variable is just a variable that helps us store the result, which is true or false. That's all the Boolean variable does. So there's this thing called if statements, right? Remember what I was talking about when you check if it's raining outside, right? When you ask yourself or you check outside if it's raining, and then if indeed it's raining, then you're gonna wear a jacket or wear a coat, right? So in programming, there's a way to write that down or to represent that. I can say if, right? To say if this is the case, or if this condition is true. The main important thing to understand is that if this condition is true, so I'm going to say if this condition, right, whatever that condition is true, then you have to actually put curly braces to represent the then. Then do something, right? So if this condition is true, so whatever I put here, it results in a truth value of true. So if the result is true, then this if statement will execute whatever is within this opening curly brace and this closing curly brace. So it will do everything. It will execute all the lines of code that are within those curly braces. That's the first type of if statement. So let me check if there's any questions. Okay, there's no questions yet. So that will be the first if statement, right? We're just gonna call this a single if statement, right? So if that condition is true, so but then the problem with this with the single if statement, right? The problem would be what if it's not the case? So what if it's not, if this condition is actually false? What's gonna happen? Well, I didn't handle that I didn't handle for I didn't put in a statement or something that handles that case. So basically nothing will happen if it's not the case. So basically if it's not raining, let's assume that we are creating an app that checks if it's raining or not. So if it is indeed raining, then you're going to wear a coat or a jacket, right? But what about if what if it's not raining? We didn't handle that case. So that's the limitation of a single if statement. But then sometimes it suffices to only use a single if statement. It's enough. It's sufficient. So now we're gonna go to what we call an if-else statement. So an if-else statement is basically this with something extra. So that extra thing is the else part. So else it just means when this is not the case. So basically when the condition is false, then we're going to handle that case here. So here we handle if condition is false. So it executes the else part if this condition over here was false. Only if and only if it was false. If it was true, then it's going to do something, right? So that's what we call an if-else statement. I know these curly braces, they can be annoying sometimes. You might forget. Practice makes perfect. Just practice every day and you'll be fine. And then we have what we call an if else if statement, right? So basically, what an if else statement is, right, is that if this condition happens to be false, let's check for another condition. So you can have as many else if statements you want. That's up to you. So I can say else if like this, right? And then the still condition is true, but it's a different condition, right? It wouldn't make any sense for you to ask the same question. That's pretty redundant, right? So this here will be a different condition. Else if some different condition is true, then do something, right? And then do something do something else, right? And then you can have another else if. You can have as many else if statements that you want. But then I'm just going to make it short and put in else. So you can now combine a single if statement and a if else if statement with an else into one big if statement. So you see this if statement, it checks a lot of things. So if the condition is true, if else if check another condition, if that other condition is true, do something. And then the else, what it does is that if all of the conditions before it were false, then we're going to handle that case. So it's like a catch-all statement. That's what the else part is. So if all conditions, because now we have multiple conditions, if all conditions were false, so if this condition was false, this one was false, and if we had another else if that one was also false, even if we had 12,000, doesn't matter. If all of the conditions were false, then the else part handles that case when all of the conditions were false. So I hope that makes sense. So that's an if those are if statements, right? So let's make an example. So remember, whatever you put inside the parentheses, right? You see this parenthesis, you should return true or false. So let me just go back to the top. Let me make an example of the if statement here. So you could do this. You could say if is raining, right, is equals to true, right? I know for advanced programmers, they'll be like, yeah, that's wrong. Why taking extra steps? Yeah, we'll get to that. We'll get to that. Patience. So if it's raining one, remember, in order to check if the left hand side is equal to the right hand side, we need to use two equal signs. So to check if this is the same as this. So that means it's going to go and fetch the value inside of this box. So this box actually does have true. So it's going to come here and replace that with true and check is true, is the left hand side the same as the right hand side? Yes, it is. You see true, true. So if it's true, true, that means this will return true, right? That's the final result. And then if true, then it's going to do something here. That's what it's going to do. So I'm going to put that back and say it's equals to true. So if it is indeed raining, right? If it's raining is equals to true. Basically, if it's raining, do something. So I'll just say maybe wear a coat, right? Or or grab an umbrella. And then what if it's not raining? We can also handle that case. We can put an else, right? For the part where it's not raining, there's two ways you can go about it. Right? There's two ways to approach it. You can say else if, and then check a different condition. So else if is raining is equals to false, meaning that it's not raining, right? Then we just wear shorts and a vest because if it's not raining, we're gonna assume if it's not raining, then it's sunny outside. So we're gonna wear shorts and a vest. So this is how you would use or go about using an if statement. But then in Java, this is pretty, and it's actually not necessary. This can be abbreviated, right? This whole thing. You can just do it in abbreviate it in what way? By removing the two equal signs and the right hand side, the operand on the right hand side of the operator. So you can just write if is raining. So you see it kind of reads like English now. If is raining, meaning that if it is indeed raining, meaning that if it's raining has a truth value of true, then I should wear a coat. And then else if is raining is equals to false. How do we abbreviate this one now? The way we can abbreviate this one, remember we negated. Remember what is the result of this one? By negating. So I'll just say if it's not raining. You see it kind of reads like English. It kind of reads like a sentence. So else if it's not raining, then wear shorts and a vest. So that's pretty much if statements. We could do like diagrams, blah blah, but then that's gonna waste time. I should have done them before the lesson, so I can't do them now. So let's go. Let's see what. Okay, we need to now talk about loops, and then once we've talked about loops, then you see it kind of seems annoying to for me to keep like talking and talking and talking and not actually starting. The thing is, I want us to start. So I want us to start when we start, right? We already know the code that I'll be writing. We understand the code. That's why I'm explaining it first. So the only thing that's left is the for loops, right? Which is loops. So why are loops important? So one thing about if statements, right? So I want you to extend on the concept of an if statement. So let's start with the while loop. I want you to see a while loop. So while loop. So okay, in order for this to work, right? Let me demonstrate it um inside. Let me actually make it. Let me actually make the what is this? The Let me actually make the app with the write the code here inside a Java file. So I'm gonna keep it simple, right? Remember, we can create a Boolean variable, right, to store true or false. So Boolean is raining. I'm gonna call it is raining, and just set it to true. And then I'm gonna say if is raining, right? Then what? If it's raining, then tell the user or the person to wear a coat or wear something warm. Whatever output you want to send to the user. I want you to understand with an if statement. So an if statement, the way it works, right? It's going to check this condition once and then it stops. It's going to terminate after checking the condition once. But then sometimes we need to continuously check things, right? Like check the operation, like whether it's true or false. We need to continuously check. And then eventually update and stop. We stop eventually, right? At some point we will stop. But then there's a reason that there's a need for that. So in order for us to understand the need, let's try to picture it, right. There's the if statement, it runs once. So you see that this will just output wear something warm. So dir, so there's the files. So I'm still in the right folder. So now I'll just say java c twang twang.java. Sometimes you can omit the dot and the backslash, but in my case I'll just put it there to say that within this folder I don't want it to look globally. I don't want it to look for it to look for the twang.java file everywhere inside of my operating system. No, I don't want it to do that. But then by default, it's not going to look everywhere. It's only going to look in the C drive. So I don't want it to look in the C drive. I want it to look for it within the current folder. So hence I'm putting the dot, meaning this current folder, and then the backslash, and then followed by the name of that file or folder. And then Java to run. So run twang, right? So, see here it's now not working, so sometimes you put it, sometimes you don't put it. So I would advise you put it only if you're going if the because it kind of makes sense why it's not working because it thinks the way you wrote it's gonna sort of like look for a file for a fold, which may kind of not make sense, right? Because if it doesn't have an extension, right, technically that's a folder, and there's no such folder called twang. So I'm just gonna leave it like this. I won't put the backslash. Even for the twang.java, I'm not gonna put the dot backslash. But then you can experiment, just play around with it, you'll see. So there's the output where something warm. You see that what we talked about, that it's only going to execute it once, right? Exactly once. So what if I want to execute it multiple times? You see, the nice thing about programming, once you master programming, you can find similarities. The only difference is I change if to a while. And then now we have what we call a while loop. And then we didn't talk about comments. Probably should have talked about it. The thing is, there's a lot involved here. So when you want to add a comment, right? So comments are just for you and other developers because when you look at this code in the near future, you forget what it does. They say maybe there's now 16 new programming languages that have been introduced, and you have to stay relevant, right? As a developer, stay up to date. So you end up not using Java that much, and you end up forgetting maybe that language doesn't actually say while. To say a while loop, you just say will like this, and then you get a while loop. So you end up forgetting, right? So comments are very useful so that when you look back at your own code and when other developers you can look at your code, they can understand its purpose, right? So I just put a comment here to say this is a while loop, right? So you see that the only thing that changed, it changed from if to a while. So it means that while this is true, and if you look at something very if you think about it logically, right? If you think about it logically, while is raining, it means that while in another way, it's like while true. This is what we call an infinite loop. I'm gonna do it on purpose because I know how to exit. Don't ever do this. This is very dangerous. It can make your laptop freeze, and the only way to stop it, you'd have to switch off your laptop. But then if you know how to stop it, you can play around with it. But I don't advise doing that. So we have a while loop here. While that's true. So let's go to the terminal and rerun it again. So I'm gonna clear. You see that we're gonna have some issues, right? So twang.java, right? And then Java twang, right? To run the Java bytecode inside the Java virtual machine. So you're gonna have what we call an infinite loop, meaning that it's not gonna stop. It's never gonna end. You see that it's gonna keep on displaying in an infinite number of times. So when I press enter, you see it keeps on displaying. The only way I can exit is by pressing Control C, right? By pressing Control C, it terminates. As you can see, there's quite a lot of repetition here. It won't stop. So be very careful. So how can we terminate the loop? So we can have what we call an update statement, right, within the loop to update this condition over here. So instead of me now outputting this thing, what I'm going to do is I'm going to output numbers. So I'm going to say int I is equals to 0. And I want to output I want to count from 0 to 10, right? Including endpoints. So including 0 and including 10. So I'm going to say while I is less than or equal to 10. Remember, this is a relational operator, which also returns true or false. But I don't know if I mentioned that when you use relational operators, they returns true. But I did demonstrate here, if you remember. Here they return true or false. So they can be used in a while loop. And then here, I'm just gonna output I. And then I want to print it on a new line every time. Hence I'm gonna use print line or print ln, which just stands for print line. So you might think this is fine, but this is not okay. It's still gonna be an infinite loop. Why? Because I is always 0. That means this will always be true. That means it doesn't eventually become false, which is the problem. So what we're going to do is we're going to run it again so that you see the problem. You need to see the problem first before you come up with a solution. So you see, it's always 0. So it's outputting zeros the whole time. So I'm going to press Control C to exit, to terminate. And then I'm going to clear. Then we're going to go back to our VS Code. And then we're going to update. So we need to fix this code. So we need to change I. So I needs to be updated. Remember, I want to count from, let's look at our problem. I want to count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, including 0 and 10, including the endpoints. So I want to start at 0 and I stop at 10. So that means I need to increase the current value of I by 1. How do I do that? So order also matters. So if you do it before outputting, there's an issue, because remember remember computers in general, or in whatever programming language you use, it reads from top to bottom. So it's going to get to the while loop, check the condition. If it's true, then it's going to execute what's inside the within the curly braces. If the condition is true, if it's not, it might not even run. That's the thing about if statements and while loops. It might not even run, not even once. So you need to be very careful in how you're handling loops. So I can say I is equals to I plus 1. In your math class, this would be an incorrect statement, but remember what the equal sign means. It means an assignment. So it does what's on the right hand side first, and then it assigns it or puts it into a variable or into a box that's on the left hand side. So it's going to take the current value of I. Currently it's 0. So 0 plus 1 is 1. So I becomes 1. And then we output that value to the user. But then already, if you're listening to what I'm saying, you can already see the problem. That means it's going to skip 0. It's going to start at 1 and end at 10. So let me save. Okay, let me Control S to save my changes. And then let me go back to my terminal, press up arrow to look at the previous commands that I ran. And as you can see, we got something that we didn't expect, right? 1, 2, 3, and we stopped at 11. So both endpoints are incorrect because of simply how we ordered our statements. Now let's do this. Let's start by displaying what's currently inside the box before changing it. Because our problem is that we need to start at 0. Currently it is 0. So it's fine. I should display that 0. Then I update it. It's a subtle difference, but you see that it changes the whole output. So I'm going to compile it again, and then I'm going to run it again. So as you can see, it's now from 0 to 10. Exactly the way we wanted it to condition here. So as long as this condition is true, the loop will keep on running. So that means we don't necessarily know how many times it's going to run. It also depends on the problem. In this case, in this problem, we know that it's going to run 11 times, right? So it's going to output 1, 2, 3, up until there, which is 11 times. So we know how many times this loop is going to run. But then most of the time, it's going to be something like this, while true. And then eventually, you leave the loop. So let's find out other different kinds of loops, right? So we have what we call a do while loop, right? Remember what I said, this while loop, it checks the condition first before it runs whatever's inside the loop. So if I was to change this to an 11, this loop, there wouldn't be any output at all, because 11 is not less than 10. You see, no output at all. That's how the while loop works. It checks the condition first before it executes. So that means the while loop runs 0 or more, or 0 to infinity times. So that means it might not even run at all, since that's what 0 to infinity means. So let's look at a different type of a loop called a do while loop. So a do while loop is exactly the same as a while loop. The only difference is that it runs at least once. So it kind of looks weird, but let's see how you do it. You say do using the do keyword, and then space, and then curly braces as usual. And then at the end, the closing curly brace, you're going to put a while keyword here, and then you're going to put parentheses, and then semicolon. And then here you can put in that condition, right? So what's the condition? So while I is less than or equals to 10, right? That's our condition. And remember, we said that we want to output before we change I. So I'm going to output this value, and then after outputting the value, I'm going to say I is equals to I plus 1 to change the value. You'll see the there's a subtle difference, right? There's gonna be one value displayed on the output instead of nothing. So let's compile it again, and then we run it again. So you see the output is what? 11, because that's what's currently inside I. So that's a subtle difference between a while loop and a do while loop. It's exactly the same thing. The do while loop, the unique thing about it is that it runs at least once. It needs to run at least once. Then now we have what we call a for loop. So a for loop, right? Remember what is talked about when we said, when talking about while loops and do while loops. Do while loops and while loops, they are used when you do not know this, when you necessarily do not know how many times the code is going to be executed. You don't know how many times this code is going to execute. That's when you use the while loop or do while loop. And then when it comes to for loop, you use it when you know exactly how many times. In this case, I do know, because I know the starting point and I know the condition, the stopping point. So I know how many times it's going to execute. So I'm going to use the for loop. So the only difference is the for loop, right? So let me go back to while loop. So okay, let me put it back to a while loop. I think a while loop is better for you to see this illustration. So while that, then delete. Right, so with the for loop, right, it's a for loop, so you're going to use the keyword for. While loop, use the while keyword. Do while, you have used two keywords, do and while. So while, and then we're going to have an initialization part, and then semicolon, and then we have the Boolean condition here, and then we have the update statement here. So let me add comments here so that you can sort of like see it. So this is the Boolean condition, and then this is the update statement. And then this would be what we call the initialization part. So let me put it back to 0, right? So a for loop, it's sort of like a condensed version of a while loop. Right, so let me show you what I mean by that. So it means that initialization, I put in this here in the initialization, and then what about condition? It's this Boolean condition over here. So I'm going to copy that, put it here, And then what about update statement? This is the update statement. So I'm gonna put it here, and then okay, so let me just change it because we can't have variables with the same name. So let me change this to x, right? So if you look at it closely, you see that it's exactly the same thing. The only difference is that the for loop is kind of like compact, it's like small, right? It has all the statements. There's this initialization statement, the Boolean condition, and the update statement. They're all there. So there it is, int x is equals to 0, x is less than or equals to 10, x is equals to x plus 1. So that's a for loop, right? It's pretty much exactly the same thing. Remember that the update statement is now here. So the only statement that I need to put here is just output. So you see that it becomes like a condensed version of a while loop. So now I can just simply delete this, and then we can leave the for loop there. Remember, I was using I. In my for loop, I'm using X. So I'm going to change here from I to X. And then I'm going to save my changes, Control S, go to my terminal, clear, and then compile, and then run. Same output. So that's pretty much what a while loop and a do while loop and a for loop is. Once you know those three, yeah, you're sorted with loops. There's extra information about loops that you need to know, but we're not gonna go into that. There's something called labels. We're not gonna get into that because now the session is gonna be way too long, which is unnecessary. So we now understand. We now have all the knowledge that's needed to print, right? And most of the things are other things I'll explain while I'm typing, right? I wanted to explain this different type of output, but we'll explain that in the next session. So now in this one, we're just gonna make it, we're just gonna, yeah, use a simple approach. So let's see. So create a trunk class. The class loops through numbers from 1 to n inclusive and prints out that number unless one of the following conditions occur. So if unless one of these following conditions occur, the value of n is provided as a command line argument, right? Yeah, this lecturers, they showing you guys no mercy. First practical, you're already doing command line arguments. So if you remember in the previous tutorial, we talked about how to get input via the scan, right? Whereby I can ask the user to enter a value, and then I use the scanner, and then I get the next int, next double, next float, blah blah blah. We talked about that. There's a way to get values from the user via command line arguments. What do I mean by that? So let's make an example. Let's see how you can do this. But there's quite a lot of things you need to understand. But it's fine. We'll go into deeper in the next session. So this is 10, right? This is a magic number, right? You won't know what that number means when you look at your code in the future. So it's like it'll be like magic, like it miraculously appeared there. They're usually called magic numbers. So this is not advisable to do, but in this case it's just an example. So we're not gonna stress too much about it. But we're going to stress about it because I want to demonstrate command line arguments. So command line arguments, right? So remember this. They said it should be called n. So int n is equals to args, right? So there's args here. So this is what we call an array. So this array is basically contiguous blocks of memory that represent. Yeah, that's what an array is. Just contiguous blocks of memory. So inside your computer, it's like there's continuous blocks of memory, each block storing one number, and each block has an index as a position. So it's like let's say for example you're in a movie theater, right? You have you have multiple columns, right? And then, or let's say rows. Yeah, let's say rows, right? You have multiple rows, and then within each row there's a seat number, right? Something like that. So let's not think about it in such a way in that manner, because in that manner it's 2D. In this case, we want to view it in terms of 1D, right? So let's take one row. So for example, you're in a queue. That would be a row, right? You can view it in terms of rows or columns. That's up to you. But picture yourself in a queue at a shopping center, right, to buy groceries. So in that queue, each person is a position number. So in our world, right, we normally start counting from one, right? We say you are the first person, so you're number one. The person behind them is number two. The person behind number two is number three, and so forth and so forth, right? So that's how we work, right? In computer science, you actually have to. There's zero index, meaning you start counting from zero. So position zero is where the first person will be, or the first thing in the queue will be stored. So I'm going to say args and then pass zero within the square brackets to say that within this collection or within this queue of args or arguments, right, get me the first thing on the first thing in the queue. That's pretty much what it means. We're not going to go into arrays, because now if I try to put in arrays and what, we might actually never even do the practical at all, because there's quite a lot involved here. So some of the things I'm just going to brush through for now, then we'll go in depth in the next lesson. So we have an issue here. So the issue is that this is a string, this is an integer, right? You said on the left hand side that you told the computer create a box with the label n that can store only integers, only numbers. But then now you want to put in a string into the box. So now the computer's like, what do you mean? Because you told me to create a box that can only store numbers. Now you want to put text into it. It's like, for example, the computer, it might be hilarious, but that's how the computer is picturing it. The computer pictures it in this sense. It's like on the left hand side, you have a microwave, and on the right hand side, you have a car. So you're trying to park your car inside the microwave. That's literally how it's viewing it. That's why there's that red squiggly line here. This red squiggly line. It means that something is not wrong. Something is not right. It even tells you that it cannot convert from string to int, because these two data types are different. Remember, they need to correspond. The value on the right hand side needs to match the data type of the variable on the left hand side. That's very important. So how do we go about converting this? Well, like I said, most of the things we go through them in the next tutorial. But let's talk about casting, right? There's something called casting. Okay, it's actually called explicit casting, right? We have implicit casting, and then we have explicit. Implicit is done for you by the compiler. That's implicit, right? In a way, some people might disagree. I don't care, but then I'm trying to make sure you guys understand. Explicit just means that it's a direct thing, right? And then implicit, it's an indirect thing. It's done indirectly, right? You don't have to get involved. That's what it means. Explicit, it's you have to be directly involved. You must do it, right? Yeah, it's a direct thing. You have to do it. It's not necessarily the case, but the term is not necessarily direct, but it's a way for you to understand it. So in our case, right, implicit is done when the data type on the left hand side is wider than the data type on the right hand side. That's it. That's when implicit casting is done. Most of the, in a generic sense, in our case we have string, which is totally two different types. It's totally two different, but in most of the time, implicit casting happens, or it occurs in the scenario, right? In that case. So what do I mean by big, right? In terms of size. So an integer, remember, is 32 bits, right? 32 zeros and ones. So on the right hand side, that means I need to have a maximum of 32 bits, something that's a maximum of 32 bits. You might give me something shorter, right? For example, we didn't talk about the data type, but there's this type called short, which has 16 bits. So you can give me something that's size 16 bits on the right hand side. It's fine. Implicit casting will be involved. The compiler will cast it for you automatically, right? So you can say this is automatic, right? And then this is manual, like an automatic car and a manual car. Manual, you have to change the gears and do everything manually. With the automatic, things are done automatically. So you just put it into drive and then you drive. The gears are changed automatically for you. So you can read in that sense also. I think this example makes much more sense. You can also, like I said, you can have a you can have a variable of a smaller range on the right hand side as long as it's smaller than the range of the left hand side. Implicit casting will be automatic casting, or implicit casting will be done by the compiler. So in my case, right, I need to explicitly cast, but then it's not necessarily about the sizes. They might be the same size, but then the main issue is that it's two different things. You can't pack a car in a microwave. It's two different things. You must find something that's suitable to be within the microwave. For example, food. So I need to cast. I want to cast it to an integer. So I'm going to use what we call the wrapper class, right? Called integer in full, right? And you see it's an uppercase letter. So basically a wrapper class, right? I want you to view it in this way. Each primitive types, right? Primitive or fundamental, that's another name for it. Each primitive or fundamental type has a wrapper class. Basically, there's a class that represents it. That's pretty much what it means. So int. So to put multi-line comments, right? This is what we call multi-line comments. You put a forward slash followed by an asterisk, and then you close by putting an asterisk followed by a forward slash. Then anything that you type here is going to be saved as a comment, because you see that it's kind of cumbersome to keep on putting two forward slashes on each line. It's annoying. So I'm just going to do it using a multi-line comment. So int, its wrapper class would be integer, and then short, its wrapper class would be short, and then double. I'm just gonna name a few. Its wrapper class will be double, and then float, its wrapper class will be float, and more and so forth. There's a lot. There's byte, there's long, big integer. Yeah, you don't have to. Most of the things you can like read the slides. They should be there. So I want the integer because I have an integer data type here. So I need to call the parse int function, right? Which takes in a string and then it converts it into a number, into an integer. So I'm passing the string. So you need to pass the string. So it's parse int because I want to convert it to an integer, right? And then yeah, there's also parse double, parse float, parse short, and so forth in each wrapper class. So if let's say I want to convert a string to a short, I'll say short dot parse short, and then I pass in the string here. And then I would say double dot parse double, and then I pass in a string here. That's how you cast from a string to a number. you have to use something called a wrapper class. So now we've done that. We have the number. Now let's use it. Instead of 10, let's put n. So that means it supports any number. It stops to any number that the user defines or gives us. So now how do we pass this value? That's the question. So to pass this value, let's go back to our terminal. We compile it as usual, right? So we're going to compile it, Java C. We compile it as usual. And then now it's time to run it, right? So run. But then to run it's not as straightforward as we've been doing this whole time. Remember, now we have what we call command line arguments, meaning they are passed via the command line or via the terminal when you're running it via the terminal. So I'm running via the terminal right now, so I need to pass in the values. So after this name of the dot class file, I pass in the value, which is n. So I need to pass in n here, which is the actual integer. So I need to pass the integer. You might ask yourself, why, if I'm passing an integer, how come I had to cast here and convert? Well, everything you type on the terminal, it's interpreted as text, as a string. So that's why we had to cast it to the right type before we use it. So let's say I wanted to stop at 5, right? And then I'm going to press enter. And then there it is. You see 0 stops at 5. And then I'm going to run it again, Java twang. Instead of 5, let's say 90, right? Let's put in a big number. And then you see it stops at 90. So that's the convenient part about command line arguments, especially when you're testing, right? When you're testing your app, you can use command line arguments to sort of like save time. You don't always have to get input, enter this, enter that. You just pass them by command line. So this would be how we approach it, right? How do we get command line, the arguments from the command line? So the way it works, right? This first value here, it will be at index 0, at position 0. It's like the person who's in front of the queue. And then 4 is the person who's number 2 in the queue. 5 is the person who's number 3 in the queue. But then remember, computers in computers we start counting from 0. So this will be 0, position 1, position 2. So that's why I used position 0, because I only want the first number, which is the position 0. So users might enter however many values they enter. I'm not going to use them. I only want the first one in the queue, which is 9. And then it's going to count from 0 to 9. And then that's all you need to know for the practical. So now let's solve the practical. It's actually very short. You'll be surprised. You'll be like, why did we have to go through all of that if this is how short the practical is? You see, get the value of n. So we need to get the value of n via the command line. We already did that. So what I'm going to do is I'm just going to remove this for loop. And then there's the part for getting the value from the command line. So by indexing, by passing that 0 for the position, it means that we are actually getting that value. So this part has been solved. So we want the class that loops from 1 to n. So like I said, the for loop is used when you know exactly how many times you're going to run the loop. So in this scenario, I need to use a for loop. Do while loop, they're all fine, but then you might lose marks for correctness because you're supposed to use a for loop. So let's use a for loop. So for, and then I'm going to say int I. They said starting, remember initialization, right? The initialization statement, it means where it's going to start from. I said it's equals to 0 because that problem, I wanted my output to start from 0. In this case, they told you that it should start from 1. So I'm going to say int I is equals to 1. So it's equals to 1. And then I is less than or equals to n I plus plus. Right, so I started 1. I starts at 1, right? That's the initialization. But then the condition is that I need to continuously check if I is less than or equals to n. And then I need to increment plus plus. So we'll talk about the incrementing and what we'll talk about it later. So let me just put it back to the way it was. This is not good. It's just that I'm avoiding to explain. I'll explain in the next video. So I'm just going to say I is equals to I plus 1. So we have this. So now this output. So what are you supposed to do? They say it prints out that number unless one of the conditions occur. Remember when you're talking about for loops, blah blah. This is where we need the else if, blah blah, if all those statements. We need to find which one to apply. So in my case, I'm gonna use the if and else if, and then else if again, and then else, because remember it might not be the case for all of these conditions. So all of these conditions might be false. So therefore I'm gonna have an if, and then else if that's not the case, check this condition. Else if that also is false, check this condition. Else it means that all of the above were false. Then do this when all of them were false. So how do we check this information? Now you need some math knowledge, right? How do we check if a number is divisible by another number? So, oh, I forgot one operator. I knew I was forgetting that operator, something. There's this operator called, remember this returns the quotient, right? And then the percent is what we call the modulus or mod operator or modulus operator, however you want to call it. So this one returns the remainder. So if this one returns the quotient, the percentage symbol returns the remainder, what remains after dividing, right? So, and it's going to be an integer, and it only takes integers. You cannot divide to find the remainder using two doubles or one of the numbers is a double or a float. No, it strictly has to be integers, or else it's not gonna your program is not gonna compile. So if the number is divisible by 3, how can we know if a number is divisible by 3? If we divide the number and we do not get any remainder, that's how we know it's divisible by 3. Well, how do we know if a number is divisible by 5? If we divide it by 5 and the remainder is 0. So that means we're actually checking remainders here. If the number is divisible by both 3 and 5, then output hop. So now you need to think about this thing in an intelligent way. The ordering of the if statements also matters. So what I'm going to do is, for the sake of time, you need to start with this one, the last if statement. You need to check for both, because you might have a number that accommodate that is both remainders. So you need to start by checking that one. Then the next numbers, the next conditions to check, it's fine. You can check if it's only divisible by 3 or only divisible by 5. Because if you start by checking if it's divisible by 3, even the numbers that are divisible by both 3 and 5, they'll be outputting banjo, which is incorrect. So I'm going to start by the last if statement. So I'm going to go here and I'm going to say if I, the current value, right, which is I, if that current value is divisible by 3, remember to say check if something is divisible, right? We find its remainder by using the modulus operator, and then we check if that returned value or that remainder is equals to 0. Because remember, if something divides it evenly, it means that the remainder is 0, right? So 2 divided by 2 is what? It goes in there once and the remainder is 0. So that's why I'm checking if it's equals to 0. I'll just put parentheses to make it easy to read. And then I'm going to say and. Remember, I'm using and because both cases need to be true. right? Remember they even told you here, if it's divisible by 3 and 5, they told you and 5. If they said or, then I was going to use the or operator. So I divided by 5 is equals to 0. So this checks if this current value is divisible by 3 and also divisible by 5, then you can output something. So system out. So what should we output if it's divisible by 3 and 5? So we need to output hop, and then if it's divisible by 3, so now I can check them individually. If it's only divisible by 3 and if it's only divisible by 5. So I can check them individually now. And then this out, and then I'm gonna go back to the PDF. So if it's divisible by 3, I need to output banjo. If it's by 5, guitar. So if it's divisible by 3, I need to output banjo. If it's divisible by 5, I need to output guitar. Else, they say you should output the number itself, if you remember the instructions, which is just I. So all the conditions have been handled, right? I've handled all the conditions. You start by checking if it's divisible by both numbers, then output hop. Else, check if it's divisible by only 3, and then if it's divisible by only 5, and then if none of them are divisible by 3 or 5, then just output that value itself. So let's test it out. So let me check here. So they stopped at 30, so I'm gonna enter 30 as my n, because they said, remember, you should stop inclusive, right? They said inclusive, that's why I also used less than or equals to, because it should include n. So let me go back to my terminal, and then let me compile. So compile, so no errors, which is good. And then here they entered 30, so I'm going to enter 30, and then there we go. So there's the output: guitar, banjo, harp. I think it should be correct. So 15 is harp. Let me just check. 15 is harp. Yeah, that's correct. And then 18 is banjo. There's banjo. Yeah. So your program is now 100% correct. They say you can use these values to test, to check your program. So I used that, I entered 30, and then I tested, my program is okay. So yeah, okay, there's also bonus. Submit the bonus as a separate, place your into a package, and then update the batch file accordingly. Okay, the batch file is not, the bonus is not that hard. You can do the bonus. So I think I should, let me see. I think I should end it here because there's quite a lot of information to take in. In the next tutorial, it'll be a continuation. We'll continue where we left off and just do the batch file. So the batch file is, you see what the batch file is for, right? It's just these commands that I've been typing here, so that I don't have to type them manually every time. I just double click on the batch file and then it runs. So that's the reason why we're gonna need that batch file. So let me just double check. I had started editing the batch file, but then remember we need to have a command line argument here, so I can put in 30 there and then enter, save. The thing is, it's not 100% correct because there's some things that are missing. That's why I'm saying we're not gonna get into them right now. We'll do that in the next tutorial. So it still works exactly the same way. So we're still good. So we're just gonna use 30 to test, and then I press enter to close, or any key. So that's all. That's pretty much it for today's tutorial. So So I'll in the description of the video, right, I'm gonna upload this code. You can easily type it, it's okay, but I'll just upload it, it's fine. So let me show you how I'm going to upload it. I'm now going to use GitHub. I'm tired of this thing of using, what is this? This thing of using, what's this thing? Google Drive. I'm tired of using Google Drive. So I'm gonna use GitHub from now on. So let me see, github.com. Did I log in? Okay, I did log in. So I'm gonna use GitHub, right? So that link that you're gonna get, right, is gonna send you to the project. So this let's say this project over here, right? Let me just open a random project. So the link that I'm gonna share in the description of the video, it's gonna direct you to some page, the page exactly similar to this. It's exactly like this, but a different name, right? Which is this project that I was just doing now. You're gonna click on code, right? And then you're gonna click download zip. So it's going to zip everything, and then it saves it on your in your downloads folder on your computer. Make sure you are clicking on local. It wouldn't be, I don't expect it to be on code spaces, but if it happens to be on code spaces, make sure you click on local and then you download the zip. I don't want to show you cloning and whatnot. That's not, the guys are not there yet. That's for final year students. So you just click on download zip. Let me show you, and then it downloads. So there's the example, right? So this is an example. And then you unzip it. Yeah, it's pretty convenient this way. And then you go inside there. In my case, there's a lot of files. In your case, it's not gonna be like that. So then you can open the file. In this case, this was a project, right? This was a Kotlin project. Well, this text editor doesn't support Kotlin. So yeah, this was a project. I remember doing it. So that's pretty much how you're gonna go about doing it. So you just click there on code and then download zip, and then you have the file. So I'm just gonna rename it to practical 0. So let me rename it. So it's gonna be called computer science to a practical 0 memo. Okay, it needs me to close here, so let me do this. Close folder. Okay, that's done. So yeah, I'll upload it right now, and then yeah, you should check the description of the video. Should be there, the link. So thanks for watching. See you in the next tutorial.